Hi there, good evening to everyone at Cohere. Thank you for this wonderful opportunity. Let's get started. So, the area of research that I'm particularly interested at the moment is dissociating language and thought in large language models, a cognitive perspective. LLMs are great at various things. It can generate human like text, it can learn complex rules and linguistic skills, it has additional capabilities like coding and summarizing, and much more. But LLMs are limited and they're not good at all of these things. Like it lacks generalized reasoning, it provides incorrect and self-contradictory result, it hallucinates, it provides dangerous and sometimes socially unacceptable answers, and the major thing is knowledge cannot be easily updated. It is very expensive to train the model, and the facts are stored in the weights. So the current approaches to mitigate this effort are retrieval augmented generations. This uses an input sequence to search external document and collections, and fuses that query with the results to generate the answer. It has its benefits and is a good step forward in the research and development, but it has its own issues. It is vulnerable to cyber attacks like poisoning of external knowledge sources. An evaluation done by four companies shows that 48.5% of generated sentences are not fully supported by retrieved documents, and 25.5% of cited documents are irrelevant. The other approach is RHLF, and this uses a human in the loop to train the model. It has its advantages too, but it seriously lacks in some aspect, like it introduces bias and damages output calibration. The other aspects are LLMs are combined with tools and agents to perform separate tasks. Uh, they all have their own shortcomings, but the concept from this paper is the paper reviews two aspects of using language. One is formal linguistic competence, which is knowing all the rules of a language. The other is functional linguistic competence, which includes understanding and using language in real world situations. Brain science shows that in humans these two skills comes from different parts of the brain and involve different kinds of thinking. LLMs are good at the first, but not necessarily at the second. So the paper proposes a modular AI, and this is the research direction that I am particularly interested at the moment. So the authors of this paper are cognitive neuroscientists and computer scientists. So they look at what evidence we have for how the brain is organized and compare that with how large language models are organized. In their account, the brain has all of these different functions and components in it. It has the language understanding and generation. It has common sense knowledge. It has factual word knowledge. Today's LLMs combine all of this into one component. They're not separated out. The problem is that we can update this factual word knowledge because it's entangled. um, it's all mixed in with the language capabilities. We can't separate out the common sense knowledge, the factual word knowledge. The common sense knowledge is slightly less concerning because common sense knowledge does not change very much. However, it's the factual knowledge we need to be updating in real time, and we can't do that right now. And they also talk about the need for episodic memory and situation model. So imagine like a situation model is something like when we read a narrative or a story or have a conversation, they say we build a situation model, which is a mental model of all the people that are involved in it, the different actors in the story, the time sequence of the events, what caused what, and that's how we understand what's happening. Now it's not clear whether the large language models build a situation model. There's some evidence in favor and quite a lot of evidence against it, but in any case it's not separated out. It's also clear that LLMs do not have episodic memory. Episodic memory is what allows me to remember what I talked about 1 week ago, or uh, I, it's about how I remember some of the places I visited last year. Right now, LLMs have a context window, which is the input to the model, and once something falls off the end of the context buffer, the system doesn't know it's gone forever. So we need episodic memory. There's also strong evidence that we have separate components for formal reasoning and planning. Uh, in humans, we also have something called the prefrontal cortex, which helps us decide on socially and ethically responsible and acceptable responses and reasoning about novel situations. So, in summary, these models are incredibly good at understanding the structure of language, but if we can figure out how to train the cognitive architecture end to end, then we can assimilate all this written knowledge that humanity has rather than to exclude it ourselves. If we can do that, we can overcome most of the limitations of LLMs, and that is the research direction that I am particularly interested in the moment. Thank you so much.